Okay, we're going live again. So, yeah, I hadn't really planned on streaming anything, but one of my teammates posted that he found an old challenge of his from something that he made in 2010, and he asked like what it would look like if you took a look at it with modern tools and methods. And also I thought this would be a good opportunity to try out my setup again, as I reinstalled my computer and stuff, so I had to reconfigure OBS and things. So I'm gonna get this started very soon. Just gonna post this stream and see if anyone else wants to follow along. So we'll be going very shortly. I'm just gonna post on my Twitter. So yeah, if you don't already follow me on Twitter, I'm available on at Ceda2. So yeah, I mean, I post mostly about security and CTF and stuff. So I think we can get this going, and also if there's anything wrong with the stream, like the image or sound or anything, please let me know in the chat, as would be nice to just fix that as soon as possible. And with that, let's get started with the challenge. So I'm just gonna close some windows. So okay, I was given this file, or a link to the file, and I downloaded it. That's all I've done so far. I haven't looked at this at all. So let's look what it is. It's a 32-bit executable. Great. So let's just open it up in IDA to see what we have. As I said, this is supposedly a challenge from 2010. I have no idea what it's about, and it might be super difficult, it might be super easy, might be somewhere in between. As I said, I have no idea. And so it doesn't. Okay. So we don't have any symbols. We also don't really have an obvious main function or whatnot. So we start here. We call this function, and then we call this function. Well, interesting. So a bunch of smaller function overall, a lot of calls. Doesn't really seem to be your typical C program, or like, yeah, it's not really a familiar structure, at least. So let's try running this. Okay, nothing happens. Possibly. Okay, so if we put in a command line argument, it gives us it exits with an error code. So does it matter? Yes, it seems to exit with error code 15. Interesting. So what's the first thing it does here? It copies this huge. Okay, so here we have like a huge buffer. So that's like a yeah. So it's a 16K buffer. Which so the address of this buffer is loaded into this register, and we then pop some stuff into other registers and call this thing. So let's just follow along in the debugger actually to see what happens when we run this. So we should break here at the first instruction. Can run. Okay, cool. And yeah, as I said, please tell me if there's any problems with the stream. So we load that into the EDI register. We then pop some stuff from the stack, and okay, so that would be the argument. If we let's run it again with an actual argument step. So popping once gives so like argv0, and this gives argv1. Yes, and then we store the pointer to that at the beginning of the buffer, I think. Let's check. No, wait. Or is it? What is this instruction? So is this like copy the whole contents of what do we have in the so what was this address again? The buffer starts here, so it's yeah, so it did store the address. Yeah, okay, so it copies the pointer to the argument into this global buffer. and then we jump here where we call some functions. I wonder why this looks like this in the linear view but breaks up. Maybe because this function doesn't return or something. Okay, anyway, the first thing will just probably then copy that pointer back. So we look at EDI, we go back 4 bytes, we copy that. It should be the same. Yeah, exactly. And then we actually then, why are we just copying it again into the same? What's the point of that? Okay, so we are putting that pointer again after the first one. Don't really see what's the point with that, but sure. And then we call the next function here, which will first in turn call this this function, which will pop something from the stack. So it will yeah, of course it will pop the return address. So it will pop this location, and then we store that into the buffer as well. Yes, so we have 2 pointers to the argv1, and then we have 1 pointer in the code. So like pointing here, and then we so how will that work then when we have since we popped the return address, we will go all the way back here, yes, and call this C8 function. Already wondering where this is going. Okay, so let's just call this one like get argument pointer, and this is get code pointer, and then we call this function, which will again just give us the location of some code. Oh, is this like setting up? Is this kind of like setting up some kind of function table? Because so these functions will, each of these functions will create let's see, if we have this if we go back, get code pointer. Yeah, so this function is called within all of these different functions, and what it does is that it takes this address, like the address following this code, and adds it to the start of this global buffer. So what we're looking at is like creating these, like we're creating a pointer to this function, I guess. So every place this is called, we create like a function to this kind of, to this gadget or whatever you would call it. I guess that's how it works. So this would then create function 1, and this would create another function, maybe, and then we come back. Yes, and then we're back here, and we jump to this function where we actually have more than like 4 lines of code. So okay, so what happens in here? Here we'll start loading stuff and doing something. So let's see, we have this the EDI register, and let's just check again. So it points to, well, okay, so we now have at the beginning of this global buffer, we have like the argument pointer twice, and then this like function 1 and function 2, which we have created. What we do here is we save that pointer to the ESI register, and now we're gonna do some more of these store. Like, yeah, I never use these functions really. So I have to look those up again. So that was a std. So set direction flag. Oh yeah, so this is controlling when you're using these load function. You can control the direction you're copying stuff. So I think now it will start. So this should probably then load some data from, or like we'll go backwards in. So we no. Yeah, exactly. So this one just gives us the 0 we're pointing to, and then we go back, skip the second function number 2, and then we go to function number 1. So this is function number 1. Actually, let's start writing some things down here. So in so the disassembly is not going to be correct at all. So basically this address is what I would call function 1, and then we have this address, which is what we call function 2. Let's see if that's consistent with what we have here. 81AB 81AB, yeah, exactly. So we load the address of this like function 1 into the EAX register. Then we clear out the ECX, and then we're loading. Okay, so the since we now have traveled backwards in the buffer again, we have this pointer pointing to the argument. We move that into the EDI register, and we then again copy stuff into, yeah, okay, so we copy that the pointer to the argument into the register. So basically all of this is just like rewinding the pointer, and then actually here we are retrieving the pointer to the argument, and then we are just checking that. So I think this is basically just checking that we actually have something in the argument. So and then we do this jump. So EDI, so E6 register is 0. Is it actually? Okay, so this is gonna be some kind of loop then, I guess. I mean, this EDI register is now pointing at the almost the start of the global buffer, and then okay, so this is, oh shit, okay, so it's like an if statement. So here we check if the EAX register, which should contain the pointer to the EAX register should contain the pointer to the argument. We check if it's set, and if it is, we set the C register. So this means that if we look again at our the global buffer, you look at the global buffer, and which should be at ESI. Again, we have the 2 pointers to the argument, and then 2 pointers to functions. So if this code was, or if this pointer was null, like if we didn't set an argument, then this would be 1, and now it's 0. And since we're starting pointing here, and then we multiply ECX by 4 and add 1, this basically means that it's like an if statement jumping either to this function or this function. So we can call this check argv1, and then if we go back to the beginning, so in the beginning here we create these 2 functions, and let's see what they're doing. the func2 I think is the easiest, because basically it just calls the exit. So this makes a syscall to an exit syscall. So basically func2 is just an exit function, and let's call it create func exit. And so this other thing is the interesting thing, and that makes sense, right? Because if the pointer is 0, CLB will be set to 1, and we will jump to the second entry here, which will exit the program, which is what we saw. So we want it to be not 0, so that we go into this part of the code. So this is where we're continuing, and that would then let's see. No, I'm not gonna get lost. So it will store hex 100 in EAX, store it to this tape or buffer or whatever, and then call this function. So here we are again setting up, I would assume we're setting up stuff in this buffer, and jumping to this check. So maybe actually this check argv1 is more of a like a if function or something. It checks some value and then it does a branch. So this is kind of like some funky virtual machine. Maybe something like some kind of like stack-based thing. I mean, we could consider this this buffer that we're working on, like you consider it like a stack, and then we're going backwards and forwards on it, or something like that. So let's let's orient ourselves again. So we will then jump into the first place, store 100 on the buffer, and then call this other function, which I should probably like undefine this function here. No. So I want this to be like recognized as one block. So the control flow analysis gets a little bit weird with this. Let's say this calling convention it uses. So anyway, we're jumping here. So okay, so we have a bunch of small instructions here. So oh yeah, now the author of this challenge actually popped into the stream, and yes, I'm actually trying to solve this challenge. It seems pretty interesting, not like anything else really I've encountered. So we should get some naming going here. Maybe, I don't know, call this like program part 1, and so what will happen in here, this function is used in a couple of places. it will just basically clear an A register, set it to 1, store it, and then jump to some other location. So this will call this code, which will so we can consider every like store is like a push, and every load is like a pop instruction. And so in this like global buffer, which we consider like if we consider this global buffer like a stack, then every store instruction becomes a like a push, and the load instructions becomes like a pop from this thing. Except no, I mean, yeah, exactly. That's exactly how it is. So this thing will push 1 to the stack. Sorry, someone is calling. Okay, that was nothing. Anyway, push a 1 on the stack, and then call this function, which, I mean, has a subtraction instruction here, so it could be like I mean, all the other stuff is just moving things around, and if we compare it to the thing down here, what we have instead is like an and a not. Oh my god. Like an and. So this could be call it func sub, and this could be like NAND. Possibly. That's the working hypothesis. And if so, if this is a subtraction, then this would be maybe then a decrement function. We take whatever is on the stack, and we subtract 1 from it. Could be. And in that case, down here, because this is almost the same, except we clear it and we do a decrement, so that's a -1, and then we subtract that. Then this could be an increment function. Interesting. And so where did we call this? We did it in this part of the program, started the program, and we loaded in this 100 here onto the stack. Oh, this is pretty fun. So just to try the hypothesis, just to make sure that I haven't got things like backwards, this should be decremented after a couple of instructions. Store the 1, jump into the subtract function, retrieve the 1, and then retrieve the 100, and we subtract, and we store it back into the buffer. Yeah, cool. Okay, so I think I'm starting to see the pattern here. So it's like a stack-based virtual machine in here, and I would guess that the argument we are submitting should then be like validated by this, and it's not that much code, so hopefully should not be too much of a problem. So after we decrement, so I guess this is some kind of loop then. We go here where we just push a 0 onto the stack, and then we go here. So what is this doing? We are checking. Let's see. So there will be a 0 on the stack, which is loaded and then moved, and then we load what is before, increment it. Yeah, let's just actually step through that and see what happens. So we push a 0 onto the stack, and as I said, like whenever I say stack now, I don't mean the actual stack. I mean like the virtual stack in the in this virtual machine. And oh yeah, so that's another. We are storing the let's see what we're looking at. We store the 0, and then we store this pointer 80cd. Oh yeah, okay, that's the exit function. Or maybe that was just leftover from before. So we load so now we will be copying stuff from copying to, I think this C register controls the amount, so we will copy from ESI to ETI. So let's look at what that means. Okay, so we copy parts of the so we're copying the argument, or So we push to 0. I'm just gonna double check now which register is it always the like which register is used for what? So it's the A register and then copied to the DI register. So let's look at this again. So we finish by now. How was this count, or how was this manipulated? So if we look again at the stack, how did it change? So we have this pointer to the argument, we have this counter, we have this ADCD, but that's maybe a leftover from previous. And then so this function here should be renamed again. So what we're doing is just like getting the, we're just moving the, we're like duplicating the copying. We're taking the thing that's on the top of the stack and then just storing again. So this is like a duplicate, like duplicate the top of the stack. So yeah, let's look a little bit more and what. Let's see if that's true. So the stack, the top of the stack would be this FF thing. So if we just would be run next, then if we look at this again, Oh no, okay. I mean EDI minus. So EDI is always pointing at like beyond the top of the stack. So EDI minus 4 is like the topmost item. So we duplicated the argument pointer. Like this was the top, and then we duplicated like this. Okay, and then we're gonna call the next thing, which pushes a 1 onto the stack. Let's verify that again. So yes, and then calls this function, which seems to be called quite a lot, and it's the same. That's this EF function. Yeah, okay, so that's called a lot, and then we do this thing. Where we make a lot of calls. Okay, let's back up. Let's look at that later. So let's see what we have here on the stack. We have this counter, we have this pointer to the argument, we have a 1 which we just pushed here. So yeah, now we should really try to see what this EF function does, because it's called a lot. So that would be very central to this program. I mean, I guess it's something about like manipulating the stack. So let's see what we have here. We have EDI, which is pointing to like at the next empty slot, or like beyond the top of the stack. We save that. We move it into the ESI register, and then we store that. So let's no, sorry, I mean, yes, the STD is not stored, it's the set direction flag. Now we're loading things in this instruction. From the ESI register. So we're just loading the top of the okay, so this is just loading the top of the stack. So this is all like one big pop. Save it into EBX. And then we load the next thing. No, sorry, we load it. why are these? Okay, so that's where we're loading the data from. Now I need to look again here. So is the B register where we're loading from? No, it's the okay, we're just stashing away this pointer. So we're popping two things from the stack and then we increment it and then we put it into the C register and increment it again. And what are we doing now? We have so we're gonna copy stuff from the ESI register to so we're copying the pointer to the argument. But why are we copying more than I'm a little bit confused. Okay. It's okay. Yeah, let's continue for now and see what happens.
I don't have anything to resume. Let me know what you'd like to play.
Yeah. Okay, sorry about that. Should disable my Alexa before streaming. Oh yeah, so now we're going down this like chain of function calls, which will eventually end up here. Where we then duplicate the top of the stack. So let's look at that again. What do we have at the top? We still have the pointer to the argument, and we duplicated it. And then we call this function, which also does some kind of stack manipulation. So we'll load the current element into the stack and then dereference it and then store that back into the stack. So let's see if that's correct. Deref, give us an A, and then we store that on the stack. Cool. So this is, we could call it like deref, because it takes the top element of the stack and makes a dereference. And this is just loads 21 into EX, and then we push that into the stack, hex 21. So, and then we call the subtract function, and so we subtract, so the first one, we subtract the second argument, or like we subtract the top of the stack from the element below on the stack. So we subtract this 21 from the first character of the argument. And then what we are so then we're setting it up like a branch here. So this is second time we do a branch. So let's name them just like branch 2A and branch 2B. So we should actually and this continues down. Oh yeah, this is again where the flow control thing is messing it up. So it should actually be, no, we should break this up again also. So okay, so it could branch to here or here, which this is okay. So every okay, so this is like the branching mechanism. So these two will be and oh look, this follows some pattern here. Let's do undefined. No, let's undefine this, restore code, and then this is a branch, and this is and so it kind of looks like it wants the first characters to be exclamation mark and a bracket or a parenthesis, but let's see what happens. So if we branch here, then we continue. Oh, this is the increment thing, and this is just a return. Let's try to see, just step until we get to the oh yeah, here we just exited, I guess. No, we're just setting up for the exit. I want to go until we get to the store. Oh no, we already... So, let's see, the first branch will be, if you look again at this if thing, so it will look at the top of the stack, so this are the two branch arguments, and this is the top, or so the branching will be basically something like we have an if instruction, and then we have the value, and then we have like jump false and then jump true, because if the thing is zero, or basically jump 0 and jump non-zero, because we check if it is, and if it's 0 we set this to 1. Oh no, okay, it's the other way around. So we check if the argument is 0. If so, we set the C argument, and that means we will take the second argument. So okay. So this is some kind of like branch on 0 or similar. So we like these yeah, okay. It would be nice to have this in, like, convert this into a more like readable way. but yeah, actually, speaking of readable, I should probably change up the font size a little bit. I see now that it's not super readable on the screen. Okay, where were we? Let's back up a little bit. So if 0, we will go to this branch, and we will, so what's this? This is a part of the code we haven't been to yet. Okay, we should properly figure out. Let's restart this thing to really figure out what this EF function is doing. I think it's like fetching from the stack downward in an offset, but just want to make sure that that's the case. Let's see where we start. So here okay, so this is the program entry. We start here, we duplicate the top of the stack, which is the pointer to the argument. Then we check if it is 0. If it's 0, we jump to the exit thing. If not, we store hex 100 on top of the stack, and we go to the program part 1 thing here. Here we decrement this pointer. So let's go there, because up until that point we understand everything fine. So this will decrement the decrement the top of the stack, and which is that counter. Let's look at it again. Yes, it's down to FF. And then we have this function which pushes 0 on the stack. Let's see if yeah, okay, so there was a 1 there, now there's a 0 there, good. And then we go into this EF function. So now let's keep things let's keep track of things. So EDI is, as we said, pointing towards the top of this stack. We move it to ESI. We set the direction flag. We load backwards, so we get oh yeah, that's the that's just like the next point. We always have to do like an extra load data, because this is pointing to garbage basically. Then we copy the ESI register, which contained, at the beginning of the program, it contained the beginning the top of the stack. So we copy that into the EBX register. We then do this load thing again and get the 0 we stored. We then increment it by 1 and move it to the ECX register. Increment it by 1 again, and we move the EBX register, which is what the point of the stack was, into the EDI register. So that was we basically just restoring we're reading downwards into the stack, and then restoring the stack pointer. So basically so far what we've done is we fetched the top of the stack, like the argument, we incremented it twice, and we restored the stack pointer, and then we're doing this repeated move instruction. So let's see, what do we have in the ESI? Yeah, so we're gonna move, we're gonna copy D words from so is this like just clearing a number of let's see, so we're just copying stuff from, let's say ESI is further back in the buffer. Yeah, so there was some complaints about the quality. I think that's like auto-adjusted due to my, I don't know, I have a pretty shitty internet provider. Hopefully we'll get an improvement on that later. Yeah, or maybe it's just that, I don't know. Hopefully it's fairly readable at least. So let's look at the source here is so ESI is pointing here and EDI is pointing here, and we're gonna copy a D word, so we should copy the FF value, and then let's see if this is, so we did this copies, and let's compare it again. So we're copying from ESI yeah, so we copied the FF from from like duplicated it on the stack, and let's see, this decreased by 4 and this also decreased by 4. So, and this will then be done one more time, and let's look at it again. So we copied first there was let's see what's done afterwards. So we're copying things back, like backwards. So now after we run this, before we started doing the copying at the ESI register, so these two, oh yeah, maybe these two then should have been copied to I feel like I'm off by one here somehow. So if we look and we then the reference like the reference this stored stack pointer, and we push that onto the stack as well, and then we clear the direction thing, and then we restore the stack stack address. So the net effect of this was basically just copying was like just fetching something further down the stack at an offset. Let's redo it and just like look at the stack layout before and after. So where were we here? and here so this is, you look at EDI, let's just save that here, and to be, so here is the next available slot, so here is like the pointer, and then we just step through this, and then we check again. It's no longer then pointing at the same. Okay, so we'll have to go with this then to compare. Okay, so this is the result, like from having but this is swapped down. Okay, what? And that's it. So basically we are swapping elements. Oh yeah, okay, so this is not actually part of since the stack is pointing here. This is just gonna go back a little bit. FF. Okay, so this is not relevant. So what we did is we swapped these two elements in the stack. And how does the argument? I guess that's would then be is it always because it's copying? Is it just like fetching one element and then just shifting everything down? So let's look at where so this would be then func like swap 1, and then so basically we decrement the counter, and then we swap up the argument pointer, and then we dupe it, and then we go into oh yeah, then we call, so this should this should be then swap 2. So let's try that. First, we will run this dupe function, and that should be in that yeah, we copied the top element of the stack. Correct, and then we're doing this push a 1 to the stack, go into this function, and now we do the same thing. We just dump the layout of the stack to see if my thinking is correct. We just step through this. And oh yeah, okay, so maybe it's actually multiple. Okay, I'm doing something wrong here. This is maybe actually not. It's. Why are these still? Or did we just? Is it actually maybe not a swap and just like a delete? But these are switched around, so. I don't get it. Let's look at it again. Let's take the whole thing, which is just this address. Oh, and so this is before the first of these function calls. We step through it. We look at it again. So are we like stashing something further down the stack maybe? And just pushing, yeah, that would make sense. So it's like a, what do you call it? Like a deep push, or let's try that idea for the other thing. That's the duplication, and then we do this other thing. So now if we do this, so this would be then doing this with 2 elements, or 2 elements down, and let's just also see where this thing is pointing. So that would be pointing here, so having this one thing. Okay, and then step through it. Dump the whole stack again. Okay, so this is what we're doing. We are storing it further down. It's like pushing it. And then we shift the whole thing. It's very strange. So in the first case, we just take this FF and insert it like one step previous, and then in this case we just take this top value and store it 2 steps below. Yeah, I guess we could still call it I mean, swap is not really the it's not the perfect name, but it's not terrible either. So basically after this manipulation we go into this, we call down this functions chain and we get to this place again. Let's just fast forward there. So we come to here, push 21, and load that into AX, and then push that onto the stack. So again, if we have that there, we do a subtraction, so we should have a 0 because I started with that as an argument, and we then go to the oh yeah, we're let's see, we've done the hey, where did we end up now? 3F8. Oh yeah, we're setting up the two branches, and then I should undefine this function and just create this code again so that it's one place. Okay, and then we go into the branching part. We should end up here in 3DA after some manipulation, and oh yeah, I mean down here. So that will increment the top of the stack, which is pointing to the input. And then call this thing and I should sort out the code here as well so we get the whole block. Okay. So if the first character is an exclamation mark, we jump here, which we'll call the increment function, and then go to the next. A lot of instructions for doing an increment, and then it will call this function, which will do the same. So then it will then deref the second character of the input, and then if that's okay, it will so this is like jumping around somehow. Because this is where we were. Now I'm getting confused here. So let's go back to the first check. And if that's 0, we should end up here. Which should check if it's parentheses, go here, which let's also undefine this and get it to one continuous block. This will then eventually come into the push 28 function, yes, which is here, and this will not be the case because I only ran the program with exclamation mark as the argument. So and then this should then, what are we doing? Yeah, we're doing the subtraction, and then yeah, that's a negative number because we had a 0 there. So this will branch into this part, which I guess will then just exit because .492, so we're dereffing. Let's look at the top of the stack. Yeah. And very soon here we will and then it will exit, correct. So should be possible then to just should be possible to just follow this these branches and put in a correct whatever it's asking for. So we started with okay, so oh yeah, okay, so this function is just a return. That's why this I renamed this previously. So let's back up again then. We sorry, just responding to a message. We okay, so that's why we have these like chains of calls down, because if we some of the branches will be just a return. So let's see here. If the first one then here down is 0, if it's an exclamation mark, then we go here, we check for so maybe we should name these. So check 21, and this is a check for 28, and this is check 29, so this would be then create check 28, or just I'm mixing a little bit here. I should just oh yeah, we have to distinguish between like creating a like pushing a pointer. So this would be, we should probably more name this like push check. So this would be and then this is push branch 2b. So okay, so we're checking like if it's not exclamation mark, then it can be parenthesis, and if it's not, it could still be, what's this? This Okay, someone asking what's on my headphone. Yeah, it's what do you call it? The ribbon from I don't know, some present I think long ago, and I thought it was nice, and I didn't want to throw it away, so I put it on my headset. It looks like this. It's awesome. So this so let's back up again. We start check if it is 21. If it's not, we check if it's I need to here I actually feel like IDA is working a little bit against me, so so this would be the increment. So this is push ink or push func ink. Now we're getting somewhere where we could actually look at this. So if it's if it is if it is 21, then we push this thing where we probably increment the argument pointer, and then we check if it is a 28, and then we jump this. Like this, they just check for a couple of very limited characters. So what are these things that we're looking for? It's let's check all these push instructions. So starting from the top. Okay, this is not those kinds of things. we're checking for a plus, we're checking for a multiplication, checking for exclamation mark, both left and right bracket. This is like a mathematical expression, and here we're checking for an A. Okay, that's about it. Those are seemingly the valid inputs, maybe, or push. This is like negative. Is this some? Oh yeah, here we're calling this NAND thing. Oh god. So we check again. We check if this is 21. If it is, we go to this branch where we check if it's 28. And if it is, then we check if. So what's this 3A thing? That's okay. First of all, it's much bigger than this. It's all of this stuff here. Basically every one of these like push func pointer will be like, it's like it marks the beginning of a like a function or something. So we don't actually have that much controlling. I'm trying to figure out like where stuff actually happens. What would happen if you just run it with so actually this block down here is one of the larger pieces of code. Interesting. Again, we're trying to check, trying to see what all these checks lead up to. Well, already been going on for like 2 hours. I thought it was going to be a quick thing, but no, this is actually quite interesting challenge though. So it will So let's actually just go for something here. Let's say that this is in fact an exclamation mark. Then we jump here, which means we increment the top of the stack, and then we check. So where were we? And then we check that it's so. Let's do this, and then we put a breakpoint. I think we should arrive here. Yes, and then we arrive here. Let's look at the top of the stack to see what's there. Yeah, it's the pointer to the argument. We can then continue let's then it should arrive here. It did not. I done something wrong. Maybe. Oh no, it actually calls. Okay, but at least it should arrive here. So let's try running it again with this. Get rid of the breakpoints. Call this. Yes, that's where we arrive. Okay. So is this trying to like parse some kind of expression then? Because we check that it starts with a parenthesis, and then we go into here. Yeah, so this, let's see, if something is 28, then we kind of like, it looks like we're like recursing, and then we check if we have a parenthesis at the end. So then it could continue. Okay, but so what are we like, what is this an expression for? Like, so so let's no, that's I wait, this should not be. Oh wait, is it this? Is this my shell playing tricks on me? Because we shouldn't have we should have taken this branch, and then no, okay, they end up in the same place anyway. But actually these things belong to, again, this. Okay, good. So this is more one function. I think I repaired the code here. Nope. Here is some code. Okay, what happens if it's not an exclamation mark, not parenthesis? Then we come here. Then we just so this is checking if we are at the end, I guess. Let's breakpoint that. So let's run this with just an A. And then check what's on top of the stack. So we have the A, and if we go so that means that if it is 0, just exit. Okay, and if not, just return. So it comes here. So that should return here then, I guess. Well, it does. So we're checking if so now we're going to compare the A against the A. So it's subtracted. Then we push the -8 here. And then so we are loading the -8, pushing it onto the stack. And then we call this function which is doing this not and thing. Why? So is that just taking the some part of the input? So in this case, if it's non-zero, we will exit. What does the stack look like now? I just have okay. Oh yeah, that's the, so it is 0. We will just return. And what would that mean? That would be basically continue here. So will we do that? Yes. This is also just a, this will always just return, I guess. Push return twice and then branch to either of them. So that's also just a return. Yeah, this is a little bit exhausting. So I don't know, maybe I'm just gonna, okay, I'll go on for a short while more and then I'll give up on this and gotta go for some dinner or something. So what is this, like, why do we take this this mask and then we hand it and then we take what does that even look like? What's the, is this, yeah, okay, so that would be a lower 3 bits not set. Then we would, so we subtract A and then we so is this, we take okay, let's look at this behavior in more detail. We run it again with just a B. So now looking at the top of the stack, we have this 1 because we subtracted A, so that's the B, and then we run this thing where we do this and not, and then we do it again. And then results in a just a 0. So we then just continue okay, so this is, I mean, basically here we have this push -8 or whatever, and this is like a push 1 and a push 0. And here's also a push 0. So so let's try running it with, so if this is some kind of mask, are we allowed to use so what happens if I put in an I here? Then we have an 8. We do this, I should just put another breakpoint. So here. And then check at the top here. Still unaffected, so what's like 0x17. Oh no, wait, actually this is, it's a 10. So what we're doing is that if it's not like a bracket or exclamation mark or a parenthesis, we subtract a and then we do something. And Then we have this function and this function, which I don't know what they do. See if we can see. Okay, let's look at this again to see what it does. We run it with C. We have the stack. And then we see what happens afterwards. So don't really get it. If you take something and AND it with itself, and then you do a not of that, let's look here to see if I'm misunderstanding something. So I'll restart this, and so it will load the all ones and the other ones and add them together and not and get a 0. Okay, so we're checking if the result of the previous call, so if you AND, basically we want lower 3 bits. So I got a question, when do you started hacking? Like today or in my life? This has been going on for roughly 2 hours now, I think. Yeah, like 2:20. Which I'm not very satisfied with. I should have been faster. So basically we want the end result to be 0 to continue. And yeah, in my life, yeah, I don't know. I mean, I started programming when I was like 7, but I started with security and hacking maybe 5 years ago, I think. So before that, I mostly did like development and programming, and well, I studied. Yes. Anyway, we want the result to be 0 because then we'll take this branch. That means that this should be only f, and that means the result of the AND should be 0, and that means that we should only have the lower 3 bits set. That should be it. So, I mean, if I input an I, this would then be ANDed together, and a NOT, which is an 8, and this should then very soon jump into the exit. Yes, okay, so it's yes. This is basically, we want to check that we are in the range finally A to H. So let's just to verify that. If I set a breakpoint here, so this hits the breakpoint, great, but if I run it with this, it should not hit the breakpoint. And if I run it with H, it hits the breakpoint. Okay, so this is our allowed inputs set. Seems to be something like this. Oh, I should probably change the okay, interesting. So what happens then? We push. If you can find out what 8122 does. Yeah, so basically we check that we only have bits according to that mask. So in this case it's like a less than check. Or like a, yeah. which I named check small. So if it's fine, let's say it's C, then we push 1 and call this thing, which will oh, maybe this is some kind of branch. So actually, if we push these two, no wait, like this is the part I don't get. This looks meaningless. So we push 1, we go in here, we push a 0, but we get the 1, duplicate it, and then we decrement that and push a 0, and swap and duplicate, and push a 0 2 times, and then we I mean, there's something I'm missing, obviously, because this makes no sense. Oh, yeah, also this continues down here. Again, the disassembly is tricking me. So oh, okay, so this also continues afterwards here. So if this would be like a loop 1, then this is push loop 1. So this is maybe we're just checking that all the, so let's see, do I ever return here? No. Now I do. So interesting. I could have 1A but not. So what are these doing? here's another big number, which should be yeah, so this is again also like a mask, or if it's like a less than, yeah, no, I should probably just give up on this. So anyway, thanks for checking in. It was an interesting little problem. Let's see if I get back to it at a later point in time to finish it up. Have a nice evening.